Alright guys, so this is a light tutor on the screen. I know majority of you have been waiting for chemistry. So you see, this is JAMB 2026. Anything you are taught here, so I want you to get your notes or your jotter and make sure that every single thing you are going to be taught, make sure that everything is intact. Make sure you always jot everything down. Mi ò gbọ́ pó, everything ó máa lọ ní mẹ́lọmẹ́lọ. Oh yeah, now let's go there. Now today I'm going to be talking about Graham's law of diffusion. No stress, you understand? So the likes of Boyle's law, Charles' law, partial pressure, law of partial pressure of gas. So you can read those ones yourself. So now today we're going to be talking about Graham's law. Graham's law of diffusion. Of what? Of diffusion. I'm going to be talking about what? Graham's laws of what? Of diffusion. Now I will let you know the Graham's law of diffusion. Alright, let's go there. Graham's law of diffusion states that at constant temperature and pressure. What does it say? At constant temperature and pressure, the rates of diffusion of a gas is inversely proportional to the square root of its vapor density or its relative molecular mass. Simple as ABC. Alright, so no stress. Just know the theorem. Once you know the law, you don't have any issues. We are going to solve problem. Marfo, we are going to solve problem. Alright now, so Graham's law of diffusion states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its vapor density or its what? Or its relative molecular mass. Now I'm going to give you some few points that you need to know before I start the problem. Now, mind you, one thing you have to know is that you have to know the formula for that vapor density. Let's go there. So just take note that the formula for vapor density is molecular mass over what? Over 2, which implies that if our vapor density to be this symbol and our molecular mass to be a capital letter M over what? This. So crossing multiplying, so which means that our molecular mass of whatever gas you are giving is twice the what? The vapor density. No stress. Alright. Also take note that when we are talking about rate of whatever, rate of diffusion. So the rate of diffusion formula is given as volume measured over time taken. Take note of this formula. Vapor density is molecular mass over 2, while rate of diffusion is what? Is volume measured over time taken. Okay? So I think this is clear now. So take note of this. So now I am going to be proving this. Alright, good. Now look at this law. They said that what? They said that constant temperature and pressure, the rate of diffusion of a gas. Alright, what they are trying to tell us is that mathematically, so let the R represent rate of diffusion. Are you with me? No stress. And what? Let our this symbol, this coffee, represents our vapor density. And also let this capital letter M represent what? Our relative molecular mass. Now, if we are now to apply this guy, so it suffices that. Now let us start again. At constant temperature and pressure, the rate of diffusion of gas, the rate of diffusion of gas is what? Is inversely proportional to the square root of what? To the square root, inversely proportional to the square root of what? Of the vapor density. Alright, so which implies that we can say that R1 to be inversely proportional to what? 1 over square root of this. So we can let this one to be density 1, and also R2 to be inversely proportional to what? Density 2. Okay, now at this junction, we now have that R1 is equals to K over square root of what? Density 1, and R2 to be equals to K over what? Square root of density what? Density 2. I'm taking you back to what you call your variation. When you are solving variation, if you want to remove this guy, it's going to become this. No issues. Alright, so now at this junction, put K to be equals to 1. Okay, so by that you put K equals to 1, which means that then we have what? R1 is equals to K over what? Square root of what? R1 equals to 1 over square root of density 1, then R2 to be equals to 1 over square root of density 2. Is that clear? No issues. Now at this junction, what are we going to do? We are going to combine the two relations. Combining the two relations. So let this one to be equation 1, and let this one to be our equation what? Equation 2. How do you combine this kind of relation? If you go back to your AP and GP, so this one is kind of similar to GP. So let's compare it with GP now. So in GP, if you have something like this, you want to solve it simultaneously, what do? You say what? Equation 1 divided by equation what? Equation 2. Alright, so which means that R1 divided by what? R2 is equals to 1 over square root of density 1 divided by 1 over square root of what? Density 2. Are we making any sense? Which implies that R1 over R2 is equals to 1 over square root of density 1 multiplied by square root of density 2 over 1. Are we making any sense? Yes. So now it becomes R1 over R2 is equals to square root of density 2 over square root of what? Density 1. In short form, this one can be translated to what? It implies that R1 over R2 is equals to what? Square root of density 2 over what? Density 1. So we have already proved this theorem out. Now proceeding further, remember they say that it is either they made mention of a statement that it is either inversely proportional to the square root of density or relative molecular mass. Alright, so we will proceed. Alright, so we are going to clear this now. Okay? Alright, are we following? So now you remember that, like I said previously now, remember that they said that it is either inverse proportional to what? Vapor density or relative molecular mass, which means that it's either this guy is equal to this, or let me just say, in summary, we can have R1 over R2, then square root density 2 over density 1, and we can also have R1 over R2 equals to square root of m2 over m1. Do you know why we are having m2? M is representing relative molecular mass, because according to them they say it is either inversely proportional to the square root of its vapor density, which is this, we concluded this, or its relative molecular mass, which is this. So it is either this or this, depending on the questions you are given. So we will now use this last equation, this guy here. We are going to use this guy to derive another equation, but mind you, you don't have any issues. Now, how are we going to use this guy to derive another equation? I'm going to take us back to where we have rate. Now, shall we move? All right. So now let me use this guy to develop another formula. All right. Recall that that our rate of diffusion is equal to what? Is equal to volume measured over time taken. Okay? Is equal to what? Volume measured over time taken. So which implies that is R is equal to V over what? T. No issues. So we can put R equals to R1 and T equals to T equals to T1. That is, okay, it implies that R1 is equals to V over T1, and if we are having something like this, obviously we should have the two part of it. That will be R2 is equals to V2 over what? T2. So the same thing applicable to this place, we are going to combine these two relations. So this one can be our equation 1 as well, and equation what? 2. Alright, so no issues. Okay. So we are continuing. Now, combining the two relations as usual. Now let's combine the two relations, which means that equation 1 divided by equation what? 2. So when we combine these two relations, so we are going to be having what? R1 divided by R2 is equals to what? Is equals to V over T1 divided by V over T2, which implies that R1 over R2 is equals to V over T1 times T2 over what? V. Is that clear? So now, this one take care of this one, okay? So at the end of the day, it implies that we are having what? 1 over R2 is equals to what? T2 over T1. So from this side, you will know that, okay, from this place, you know that we are having R1 over R2 is equals to the whole of this, which means anywhere you see R1 over R2 here, you are going to input this one. Anywhere you see R1 over R2, you are going to input this one. So, given or recall that R1 over R2 equals to square root of M2 over M1. Hence, we now say that anywhere we see the whole of this, we'll put this one. Then we're having T2 over T1 is equals to square root of what? M2 over what? M1. So that's it. This is the last one. So this law brought us to 3 equations. And what are the equations? Therefore, Graham's law of diffusion produces 3 equations. And what are they? The first equation was the one we got initially was R1 over R2 is equals to square root of density 2 over density 1. Then the next equation was R1 over R2 equals to square root of M2 over M1. And lastly, the last one is T2 over T1 is equals to square root of M2 over what? M1. So as you can see, this is the whole narration of Graham's laws of diffusion. This is, at the end of the day, we are proving what this was going to result to. So at the end of the day, we are able to finalize these three equations. So depending on the equation you have, that will determine the one you are going to use. No issues. Now we shall be solving two problems in this topic. So please, if you are getting it right, drop a comment in the comment section, give us a thumb, and make sure you share. So I shall be writing a question for us to solve now. If you're a JAMB, this is for you. If you're a WAEC student, this is for you. Alright. Certain volume of hydrogen gas diffused through a porous partition in 25 seconds. Calculate the time required for the what? For the same volume of hydrogen chloride to to diffuse. Yeah, making me to laugh. Guys. Alright, so we are having two things here. We are having the hydrogen gas and we are having the what? Hydrogen chloride gas. You understand? Hydrogen chloride is an acid, but regardless, we used to have the gas too. So we are having what? Two compound here. We have the hydrogen gas and we are having what? We are having HCl, HCl. Good. So now we need to calculate for the relative molecular mass of this. So what's the relative molecular mass? The relative molecular mass of, let's say this one to be 1 and this one to be our 2. The first compound and the second compound. So our M1 here is what? Our M1 here is 2 times, if you are to calculate the relative molecular mass, that's 1 times what? 1 times 2. The 2 that you are having here. So you're having what? You're having 2. Alright, so for this place now, the M2 now, what will be our M2? So this one is what? 1 plus this one is what? 35.5. So by the time you add it together, so what are we having? We are having 36.5. No stress. Alright. Proceeding further. So they said a certain volume of hydrogen gas is diffused through a porous partition in 25 seconds. So this time is going for what? Hydrogen gas, which means that, you know, I said that this one should represent the first compound. So which means that our T1 here is what? Is 25 seconds. Chicken now. Our T1 here is what? 25 seconds. And our what? Our T2, if our T1 is 25 seconds, so what will be our T2? Our T2 is what we are looking for. That is the time rate for hydrogen chloride to diffuse under the same condition. That is what we are looking for. So now, among these equations, it is obvious that we are going to be using this one. Because based on the parameter we have here, it is obvious that we are going to be using this guy. So, using what? Using what? T2 over T1 equals to square root of M2 over M1. So, now we are going to be using this equation to solve this problem we have here. So, our T2 is going for the time rate of HCl, and our T1 is going for the time rate of H2. That's the idea. So now, substituting what we have, the parameters we have here. So what are we having? We can just be like T2 over 25 is equals to square root of M2 36.5, and our M1 is what? Our M1 is 2. Alright. So we now have 36.5 divided by 2. So we are having T2 over 25 is equals to square root of 18.25. So this one becomes T2 over 25. What's square root of 18 point? So we're having 4.27. So by the time you cross multiply, you're having T2 is equals to 25 into 4.27. So multiplying it, we're having 4.27 multiplied by 25. So at the end of the day, we're having T2 is equals to 106.75. So which is approximately 106 seconds. So this is the time rate. This is 7 seconds. Alright, so that's our final answer for the time rate of HCl to diffuse. So we are going to be solving the next question now. I hope you understand this. no stress, it's not hard at all.